Today we're talking about precipitation reactions. And this is where two aqueous solutions are mixed to produce an insoluble solid called the precipitate. So two aqueous solutions means two solids that are soluble in water. We talked about solubility rules yesterday. So two soluble compounds in water mixed together, and two of the ions, a positive and a negative, combine to form something that's insoluble. And once they combine to form something that's insoluble, they're solid. They can't separate anymore. Does that make sense? Okay, so an example. Silver nitrate is aqueous. According to our rules yesterday, silver nitrate dissolves in water because of nitrate. All nitrate compounds dissolve in water. Aqueous just means that thing dissolved in water. They're solid, liquid, gas, and aqueous. Okay? Plus potassium chloride, also aqueous. If you remember from part 1, this is a double replacement reaction, double displacement. You remember the types of reactions? In this type of reaction, the positive of this one attaches to the negative of this one. And the positive from this one attaches to the negative from this one. And then it's your job to write them balanced. In this case, they're 1 plus and 1 minus. So AgCl and KNO3. And then you have to ask yourself, is either one of these things insoluble according to the rules, and therefore it precipitates is the word. Is either one of these things insoluble? The silver chloride is insoluble, so it forms a solid precipitate called a precipitate. And the potassium nitrate stays dissolved in water, so it's still aqueous. Isn't that lovely? All right, let's do another one. Sodium sulfate and strontium nitrate. Positive to negative, positive to negative. I wind up with strontium sulfate and sodium nitrate. I have to balance and put a 2 there. Don't forget things like strontium is 2 plus, group 2. Sulfate is 2 minus. So that's why we only need one of each. But here, sodium is 1 plus. Sulfate is 2 minus. So I need 2 sodiums and a sulfate. Don't forget to balance your compounds. That's still important. And don't forget to balance your reaction. Okay, so now we have to decide either one of these insoluble. Strontium sulfate is insoluble, so it forms a precipitate. Sodium nitrate, soluble. Let's do one more. At this point, we go sodium to chloride, potassium to nitrate. Potassium nitrate, sodium chloride, will either one of those be insoluble? Nope. They both have a group 1 compound in them. Group 1 group 1 ions are always soluble. There's no way you can make a precipitate here. So you're going to dump them together, and what are you going to see? You're not going to see anything. If you don't form a precipitate, we say that's no reaction. You don't form anything new. You just get ion soup.